Good morning. We're looking at problem 3, modeling and inverse variation. It says your math class has decided to pick up litter each weekend in a local park. Each week there is approximately the same amount of litter. The table shows the number of students who worked each of the first 4 weeks of the project and the time needed for pickup. So we have 3 students, the time it took is 85. 5 students, the time that it took was 51. 12 students, the time that it took was 21. And 17 students, the time that it took was 15. It says what function models the data? So investigate the data. The more students that help, the less time that it took. That makes sense. An inverse variation, it seems appropriate. If this isn't an inverse variation, then NT equals K. So I put it in my graphing calculator. It's a free calculator at www.desmos.com. And as you can see, we have 3, 85, 5, 51, 12 students, 21 minutes, 17 students, 15 minutes. And let's graph it. Oops, not zoom in, but zoom out. There we are. And so that's kind of what my graph looks like. Same thing here that they have. And it says that when I just put in my calculator x1 times y1, and it gave me the multiples of these numbers here. And as you can see, just like they said in the book, most of the time we got 255. So that means that it probably is an inverse variation. So the model would probably be NT equals 255. Alright, so how many students are there, how many students should there be to complete the project in at most 30 minutes each week? So we know N stands for the number of students and T is for time, and we know that we have 255. So we're going to plug in 30 for our time and see how many students that would be. So number of students times 30 minutes equals 255. To solve for N, I'm going to divide both sides by 30. And I get N equals 8.5. Can't have 8.5 students, so we'll say about 9 students. It should take about 9 students. Alright, so now let's do another problem. Let's look at got it 3. Let me clear my board. And it says, let me get my new chart. Just add table. And it says, after a major storm, your math class volunteers to remove debris from yards. The table shows the time, T, in minutes it takes for group N students to remove the debris from an average size yard. So we'll put it in 1, 3, 5, 14. And the time is 2:25, 75, 45, and I forgot the last number, 16. Okay, and I can just come over here and I can say x1 times y1, and it gives me my values. And as you can see, most of the times, and here's my graph as well, and as you can see, most of the time I am at 225. So that means that my function is NT equals 225. Okay, so what function models the time needed to clear the debris from an average size yard relative to the number of students who do the work? And we just said that was NT equals 225. Then it says, how many students should there be to clear the debris from an average size yard of at most 25? So, oops. So we'll say N, what did they give us? 25 minutes. And we want to figure out how many students that is. So I'm going to divide both sides by 25 to find my number of students. And we can put that in our calculator. So we have 225 divided by 25, which gives me 9. So we need around 9 students. I hope this helps.